The topic is Federated Autonomic Management of End-to-end Communication Services. It's very technological level, but we have some input from social concepts as well, social formats. So briefly, very briefly, I am coming from the Watford Institute of Technology in Ireland. It's established in 1970, around 10,000 students and 1,000 staff. Considering the size of Ireland, it's one of the biggest technology centers in the southeast of Ireland. We are located just in this part, in the right-hand side of your place, of your city. And we have 4 campuses. We are working in Carriga North Campus, which is the scientific and the innovation part of the science. Okay, so what we are doing at the moment in the future internet, we have a very big scope. We have some kind of applied projects, some kind of a basic projects too. We have some, you can see here some of the projects, which is even societies and perimeter. They were presented before me. And I am the top on the right-hand side. I'm working in FAME. But I was working as well in FutureCom, so we have some inputs in the basic and interdisciplinary approaches about science, about future internet solutions. Particularly, this presentation will focus in the cloud computing area because it's one of the topics that we are focusing in FAME. So FAME is about, as I said, federated values chains, which is technology chains in the computing science. The autonomic behavior of the networks, how to make the faster solutions, how to make more intelligence in the network, and how to manage the quality of services and quality experience, how to make the services, how to make more efficient the services using the technology side. And the end-to-end communications, how can produce software solutions for the end user. So this is pretty much the perspective. And our slang is the solutions for the complexity in future internet communications. So as you can imagine, this is a very huge project. We are touching some of the main areas in the future internet. We are talking about Internet of Things, future service architecture, future network architecture, and obviously internet and socioeconomic aspects. So my concentration is in technological side, but as I said, I was working in the other project, and it was more socioeconomic aspects about the studies, about how to use trust, identity, social networking models to the networks and to the services. So my presentation will concentrate at the moment in cloud computing, and it will be more than just talk. It will be a video at the end, so probably that will be more exciting for you to see. So one of the topics, or one of the approaches in cloud computing is how to use the core networks, the core infrastructure on the right-hand side, and how to interact between these networks and how to access them, to approach, how to use them, to produce new services, customer services, and how to make more efficient these kind of services. So I will go through the concepts, but you can check it in the website. So trying to summarize all these concepts, all these approaches in the project is we have 3 strands. And as you can see on the top, we have federated service management, which is how to interact between different technologies, how to interact between different end user services. In strand 2, we have a service monitoring and configuration. It's how to detect useful information from the network, core networks, and how we can produce some reactions, and how to produce new services based on those reactions. And the strand 3 is pure core networks, how to make more efficient using optical solutions, protocols, paradigms, IPv6, IPv4. So this kind of 3-level approach is that we are working on. Cloud computing, you can imagine, is in the middle between strand 2 and strand 3, right? As I said, you can check the project portal, and you can see all these explanations more in detail. So cloud computing is in plain English. So many of us are involved now in cloud computing. Is that an accident, or is it just a trend in technology? It's just a trend in social or in marketing. So that's one of the questions. I will not go to the definition, but it's just cloud computing services are more efficient, are more accessible anywhere, and it's more easy to interact with the services, with the technologies. Okay, so from an end user perspective, what we can expect from cloud computing. So we expect to have services in the cloud. Yes, voila. We can have mobile technologies, web applications, office solutions, internet applications for end users. And we can see one example. Microsoft is using 365, which is Office in the cloud. So we don't need to install, we don't need to deploy any software in our computer. We just have internet access, and we go to use Office tools in the cloud. So this is one of the end user perspective. Unfortunately, for technology side, it's more complex. So we have cloud infrastructure, we have to deal with clients, we have to deal with applications, platforms, and we have to interact with cloud platforms too, because we have at the moment different platforms like Amazon, like IBM platform, even Mac is deploying in this year. It will release this year the iCloud. So these kind of platforms we have to deal with. We have to negotiate between them, and we have to create federations as well, and new services on the top. And in the application side, which is end user, we have to provide new services support for this growing technology. The background of cloud computing is why cloud computing is so important at the moment. So it's probably one of the questions that everybody's asking. The innovative part of cloud computing is not the technology side, unfortunately, but we can concentrate in social aspect, because in 2010, one of the main requests from the budget in US was move to the cloud. So Barack Obama was indicated to move to the cloud. So this is one of the answers of the questions why we are moving to cloud computing. In Europe, obviously we have different objectives. Probably this is a good start of the debate in the next part of after the launch. So another point of view of society and technology, if cloud computing is leading, is does the need of new technologies, are those necessary to deploy new solutions like cloud computing, or is just a demand of the society to go to that social network environment or this kind of a new perspectives? So the benefits are obviously in place. I will not go through this one. You can actually access the slides probably later. And also there are some disadvantages in cloud computing that we can discuss probably, and you are invited to come after launch to the cloud computing session. Some business level challenges as well. And as I said, the most important for my perspective as a technologist or as a cloud computing research is try to define the trends in cloud computing, how we will achieve the objectives of cloud computing. At the moment, we have infrastructure as a service as a main topic, but we need to deal as well. We have to be visionary and futuristic and see how the cloud computing, private cloud, public cloud, several clouds working in place most interact and most exchange information as well. So this is one of the challenges, big challenges. To achieve this one, I will invite you to imagine one of the most typical services in cloud. So we can have at the moment, if we want to start a new business, maybe we can start a website and we can sell videos. It's not a YouTube, it's not a Facebook, it's just videos, high quality videos based on demand. The user has to be able to download videos, and as much as the users come up, we have to deploy more technology. We have to satisfy that request. And obviously we have to have the system to support that demand with the same quality of service, with different parameters. So imagine this one. We have a small testbed. We have some video on demand with video servers, and we have cloud management system, and we have some users, right? At the beginning, we have a startup. We have a very initial cloud computing startup. And we have some scale request. So we have here some virtual machines working, and we have to deploy them automatically, right? But what happens if there is some traffic change, networking conditions change? So we have to be able to undeploy that infrastructure to give more broadband, to give more freedom to the users. But we have to keep alive, because probably in the next phase we will request another deployment in the cloud of the services. But also we have to be able to destroy or to uninstall that infrastructure. So that's the main problem, because at the moment, or people has to be concerned, do I have to spend too much money? Do I have to invest a lot in different servers around the world? Or I can use just one powerful solution and then just go and pay, which is one of the trends or one of the challenges in cloud. Okay, in this scenario, the solution is virtualization. Virtualization technologies can provide us this fact or this feasibility, this advantage. So we can come up with technologies like virtual technologies, and then we can just satisfy this demand. We can even change the topology of the network. So this is the control loop. Trying to translate in that complex scenario to try to simplify the problem is we have some video client, we have some performance monitoring systems to locate the different points of the network. We have some virtualization, some visualizations, and some network management systems working permanently to satisfy the demand. And we have some cloud infrastructure that we can be deployed or not, can be accessed or not, can be even modify the infrastructure. So this is the control loop that I will demonstrate to you in the video. So as you can imagine, we are not obviously touching all these topics because it's a problem that it's not been solved totally. But we have some performance analysis, investigation, some service lifecycle operation and control, and some virtual machines at the moment. So to close the control loop, we are just sending information from the users. We are just some data files, some profiles, some basic performance data, and we can reproduce this data and translate to the high-level descriptions into the management systems. And then the users can use these descriptions to satisfy their demands in the service. We will see the video immediately. What you will see in the video is a website. You can see a website when you can choose the videos. In the same scenario, you can choose one of the videos, and then we will see how the systems in the background react to that request. We will see some video servers working in parallel in virtual infrastructure, virtual machines. We will see some monitoring systems bringing the information from the network and translating, analyzing that information to the systems, and we will see how the systems react based on that performance information. And we will see the management system. Sorry about the quality is very blurry, but you will see that in the left, this is the cloud infrastructure management. On the right-hand side, you can see that there is some events, that is semantic descriptions from the high-level descriptions, and down there are some performance values from the low-level applications, this networking information. And for those people interested in the technology side, we have some virtual machines. We have 2 servers, and we have several virtual machines deployed on those 2 servers in the cloud. So you can see some management decision control. You can see some information management as well, and some kind of a management decision support. Okay, so let me move to the video. This video will be very quick. It's just not more than 5 minutes, and I hope you can enjoy it. Okay. It's a little bit tricky. Those are the same video running different virtual machines based on the request from the service in the cloud, from the service in the website. This is the amount of information that we receive from the sensors in the network, and we are just processing the data on the right-hand side to identify those parameters that we can use to deploy virtual infrastructures. Huge amount of data. So we have to produce systems that can react, can identify, can understand this process. On the left, we are controlling the service lifecycle of the clouds. It's actually creation, deployment, suspend, react, stop, delete. How we can control the virtual infrastructure automatically using some semantic descriptions and some performance values as well. On the down part, we have just memory performance, CPU usage, and disk transfer rates, some values in the network. On the top, we have just instructions: create, deploy, stop, remove. These kind of semantic applications that users can understand, but they are translated in the different domains. So the virtual machine invocation has been created, but it's not deployed yet because the system is ready in the control loop. then when the users will request deploy to me a cloud or a virtual infrastructure, then we will see the reaction. One of the virtual machines has been created, and we can control the rest of the processes: suspend, reactivation, and stop, delete, basic operations in cloud. As you can see, it's a cycle, service life cycle we are just controlling, and we will see how it's paused now. And after a while, we'll reinvocate the same infrastructure to come up again to satisfy the same service, BD on demand. And then we will delete it as well. We will remove the virtual infrastructure at the end. It's nearly the end. Okay, it's come up now and will disappear once. Yep. So scalability, one of the topics, one of the problems is how to control many virtual machines, many infrastructures at the same time. So on the top, you can see one of the infrastructure, a different infrastructure on the low level. We can have even Amazon or even IBM technologies working in parallel, and we can control on the high level description on top of them, for example. Yeah. Actually, you can see here, just finally. Yeah, but you can see here there are two virtual machines working in parallel, and here you can see how the systems react. Here is automatically, this is not manual at the moment, and you will see just automatic processing, and two virtual machines will come up automatically. So this is pretty much the reaction of the network. Okay, so thank you very much. Thank you for attention. And just before going, I will to invite you to the tall ships races in 2011. It's in Waterford this year. So the tall race ship will go departure from Waterford and go to the Hamstad in Norway. So please come up. You're all very welcome.